Hello guys, my name is Mohammed Hussein. Module 6, Lesson 4, Metallic Bonds and the Properties of Metals. Here's our focus question. How do metals and ionic compounds compare and contrast? We will have new vocabularies, electron C model, delocalized electron, metallic bond, and alloy. Physical property, a characteristic of matter that can be observed or measured without altering the sample's composition. In metallic lattice, the outer energy level of the metal atoms overlap. The electron C model proposed that all metal atoms in a metallic solid contribute their valence electrons to form a sea of electrons that surrounds the metal cations in the lattice. Here we have nuclei or positive charge of atom that's surrounded by a sea of electrons. These electrons are overlap each other. The electrons in the outer energy levels of bonding metallic atoms are called delocalized electrons because they can move from one atom to the next. When an atom's outer electrons move freely throughout the solid, a metallic cation is formed. A metallic bond is the attraction of metallic cation for delocalized electrons. The physical properties of metal at the bulk scale can be explained by metallic bonding. These properties provide evidence of the strength of metallic bonds. Examples of physical properties of metals: we have melting and boiling points, thermal and electrical conductivity, malleability, ductility, and durability, hardness and strength. In general, metals have moderately high melting points and high boiling points, as shown below. Here's the table. We can see that the melting point and boiling point for metals are very high. The melting points of metals are less extreme than the boiling points because the cation and electrons are mobile in metal. It doesn't take much energy for them to move past each other. During boiling, atoms must completely separate from the lattice. These require more energy. The movement of mobile electrons around the positive metallic cation makes metals good conductors. Mobile electrons move heat from one place to another quickly. Mobile electrons easily move as part of an electric current when an electric potential is applied to a metal. Metals are malleable, can be hammered into sheets. Metals are ductile, can be drawn into wire. The figure below shows how an applied force causes metal ions to move through delocalized electrons, making metals malleable and ductile. Metals are durable. Metallic cations are strongly attracted to electrons around them and not easily removed from the metal. As the number of delocalized electrons increases, so does hardness and strength. We have new vocabulary here. An alloy. An alloy is a mixture of elements that has metallic properties. For example, stainless steel, brass, cast irons. The properties of alloys generally differ from the properties of the elements that they contain. For example, steel is ion mixed with at least one another element. Some properties of iron are present, but steel is stronger than iron. Here's the table that shows us the commercial alloys. Alloys are classified into two basic types. The first type is substitutional alloy. Some of the atoms is in the original metal are replaced by other metals of similar atomic size. For example, we have sterling silver. Interstitial alloy. This alloy is formed when the small holes in the metallic crystal are filled with the smaller atoms. For example, we have carbon steel. These small holes are filled with the smaller atoms. Quiz number 1. Which of the following is true of the electron C model? Identify the name given to the attraction of the metallic cation for delocalized electrons. What do the physical properties of metals at the bulk scale provide evidence of? Which of the following is not a property of metals? Which of the following is true of alloys? Thank you so much. See you on the next lesson.